Okay, so I'll start with the introduction. Hello, everyone. Welcome to our 9th Bilkent STS event. My name is Nashiha, and I'm a Bilkent CS graduate. So I'd like to give Dr. Stelvia Matosz a warm welcome, and I'd like to give you all a warm welcome to our video conference. Our conference is on utilizing life cycle assessment as a proactive approach for sustainable product development. And I'm going to talk a little bit about Dr. Stelvia Matosz. She has a PhD in civil engineering and is a reader in social innovation and sustainability management at Surrey Business School, University of Surrey in the United Kingdom. Her research concerns the difficult process of how industry can change their practices in response to social and environmental pressures. Her research interests include sustainable supply chain management, sustainable technological innovation, and entrepreneurship for social inclusion. She has published in several journals, including Journal of Operations Management, Technovation, California Management Review, Small Business Economics, Journal of Cleaner Production, and Journal of Management Studies. Dr. Stelvia Matosz is currently area editor on sustainable development innovation for Technovation. So please join me in giving our Bilkent best. If you're ready, Dr. Stelvia Matosz may begin, and we'll reserve the end of the event for questions.
Thank you so much for this opportunity. I'm delighted to be part of this experience. Talking to you from such distance. I'm currently in Brazil conducting research with my collaborators. So this is an amazing opportunity, and it's wonderful. Thank you so much for providing this experience. So let's start with our presentation. This work was conducted in collaboration with Dr. Jeremy Hall, which is the director of the Center for Social Innovation at Surrey Business School, and also our dear colleague Adi Bahi from the Department of Materials Engineering at the University of British Columbia in Vancouver, Canada. So it was a nice multidisciplinary collaborative approach to this research. Just trying to go to the next. Oh, there you go. So a quick presentation overview of what I'm going to talk about. So just to set the context of this research, I'm going to talk a little bit about supply chain research, specifically in terms of interdisciplinary perspective and proactive perspective as well. Then I briefly mention the challenges of new product development, which you may find interesting because it's quite a fascinating area to look into. And then we go to a practical example where I talk about the lignin-based resin technology that the scientists at University of British Columbia were developing. And then we'll wrap up with some implications and conclusions. So to talk about supply chain research, I'm quite pleased with recent calls for a more interdisciplinary perspective of the issues and the challenges related to supply chain. So there has been a need to do more research that integrates economic, social, and environmental issues in the early phases of supply chain management. The challenge is that many tools and frameworks that address the impact of resource production and consumption, for example, that also deal with environmental, socioeconomic issues, most often, I have to say, treat those different areas very separately. I'm sympathetic with this because it's not easy. It's very difficult to see the interactions between environmental, socio-economic. It's a very complex part of the sustainability research. And I'm sure that Robin has mentioned those challenges during her course. So an interdisciplinary perspective, though, to supply chain research is seen as an opportunity to develop research that integrates these different dimensions and provide some interesting and insightful new solutions and new directions to what we do, right? To provide benefit to the technology development, to society, and elsewhere. Having difficulties. Oops. Going to the next slide. Oh. Okay. At the same time, well, you may be familiar, of course, with life cycle assessment as an environmental management tool, and it's often a topic of discussion within the supply chain research because of its nature of considering the issues related to set the raw material to the disposal, right, of new products, of processes. So developing tools such as life cycle assessment at later stages of product innovation has been acknowledged as not being that effective as we can be as conducting life cycle assessment study at the beginning or at the early stages of product development. So the importance of proactive approaches has been widely explored in new technology and new product and process development in literatures. So this is also a recognition which is very interesting as well, to try to explore all these opportunities for change things and making things better at the beginning when things are being developed. And this relates quite closely with the literature on new product development. And one seminal paper is by Clark and Wheelwright from 1993, where the authors try to explain basically a number of new ideas happen mostly in the beginning or new technology, right, or a new concept. And as at this phase where the new ideas, high number of new ideas are happening, it's also high the ability to influence the outcome. However, what actually happens is that many activities don't happen in the beginning. It happens quite later on in the commercialization process. And the problem is that it's much more complicated to make changes at that point, because at that point, many compromises have been made already. And so that means that time and costs are very difficult issues to deal with at this point. So they also recognize and acknowledge the importance of acting early at the early stages of technology development. What these authors also suggest, and quite useful tool as well, is looking to the development of technology through a funnel. So we can see here in the top square that you have at the beginning a high number of ideas as well at the beginning of development of technology. And what Clark and Wheelwright suggested is that at this point you should involve technology assessment and forecasting actions, and also the market assessment and forecasting actions and people to dialogue and act in this beginning. So they can give useful inputs and more, for the diffusion and adoption of the technology. What Hall and Martin suggested is that in addition to technology inputs and marketing suggestions and inputs, you also should at this point include organizational information and social information about the technology. And this is because in terms of organization is that it's not always the company or the organization that developed that technology is going to be the one that is going to benefit from the commercialization of the technology. So it's important to look into whether that organization has the right complementary assets like access to market, the right skills and capabilities to turn into that technology into put into the market. And social assessment is related to the social acceptability of that technology. Sometimes great ideas are developed in the lab, but society does not accept that new idea, and so there are huge problems in terms of adoption and commercialization of that technology. So basically, we are suggesting that in addition to all this input of technology and product and market strategies, we should also consider societal environmental strategies in the development of a technology. Now I'd like to talk a little bit more about a practical use of this idea and this concept. So I'm going to present a case study that we developed in Canada. I had the privilege to work with wonderful collaborators, including Robin, in this project. Genome Canada is a large-scale applied research project. So just to explain what Genome Canada is a not-for-profit mandate. It has a not-for-profit mandate to develop and implement a national strategy for supporting large-scale projects and proteomic research in Canada. And what is interesting about this project is that it required a GELS component, which stands for Genomics-Related Ethical, Environmental, Economic, Legal, and Social Issues related to technology being developed. So this was in reaction to addressing public concerns in Canada over genomic technologies, and also the recognition that the linear technology push model actually left some promising technology sitting on the shelf. And another interesting component of this project is that all grants needed to emphasize benefits to Canada. So it was a call for collaboration between scientists and social scientists in order to assure that the grant and the funding that was given to this project would have a return to the society. One of these projects related to lignin transformation technologies for sustainable biomass products. So the University of British Columbia had a team of scientists which were using genomic approaches that could transform lignin to replace petroleum in a number of different products, like food additives, resins, carbon fibers, and biofuels. For those that don't know, lignin is the substance that keeps the cellulose together in biomass, and is actually a very rich source of a component that you can produce many things. So the scientists were proposing a new lignin-based phenol formaldehyde resin, which we can short it as LPF, that could reduce environmental impacts while also providing an economically competitive alternative to petroleum-based PF resin, so the traditional resin. Phenol formaldehyde resin is a synthetic polymeric material used to improve hardness, dimensional stability, heat, moisture, and chemical resistance in a number of structural panels such as plywood and oriented strange board. So if you look around in your room where you are right now, there will be phenol formaldehyde resins all over. They're covering the tables, part of the chairs, and perhaps the walls and the equipment as well. It's a very highly utilized chemical substance. So the building and construction industry account for most of the PF resin produced in the US, where it's regarded as the most cost-effective type of adhesive. And just to help you to visualize what it takes to produce the lignin formaldehyde resin that was being proposed by the researchers at University of British Columbia. This is a simplified flow chart of the resin process. So the blue part shows that would be a regular pulp mill process. And then you have the black liquor, which is seen by some as just a residue of the pulp mill process, and by others as actually a byproduct of the fabrication of paper and the pulp mill processing. So regularly, this black liquor, which is is very rich in organic matter, is burned to generate energy for the pulp mill. What we were proposing is to, instead of engaging this low value activity for such a rich organic component, we would separate the lignin from this black liquor, and that requires a number of inputs in terms of chemicals, which I'm not going to get into detail here, and produce the lignin phenol formaldehyde resin. And that would actually replace, the suggestion is to replace part of the traditional resin used in the market in a more environmentally friendly way. So to conduct this research, we applied what we called the LCA TCS analytical framework. And I just explain how it works. So usually we'll start consulting with the scientific team to identify who are the key stakeholders related to the development and adoption of this new resin, and what are the key issues that related to the development of this with the resin. So with that, we'll identify a list of important stakeholders, of key stakeholders that we should talk to. And then we'll go to the field and interview those stakeholders. And in looking in the interviews of those stakeholders, we combine qualitative and quantitative data. So we had quantitative data, related, for example, issues related to production scalability, product consistency, durability. So basically the product performance of this new resin. We also had quantitative data related to commercial issues such as consumer needs, willingness to pay, industry structure, preliminary cost assessment, and issues like that. But then we'll also combine qualitative data, which would involve regulatory hurdles, public perception about this new technology, possible environmental impacts, social and environmental benefits, comparing to the traditional resin. So throughout this process, we would try to use any useful information that could help us develop a preliminary LCA, of course, because at this point, the technology is being just developed. So there are a lot of imperfect information. There's still a lot of lab work being done. But the idea was to try to conduct a preliminary LCA with as much useful information as possible from those interviews in terms of what are the key environmental issues, if there are any specific concerns that LCA could help to address, and give some useful information back to people from industry, for example. So our qualitative data was composed of 80 stakeholders interviews. We spoke to forestry and chemical industry representatives, trade associations, government representatives, NGOs, academia, all those stakeholders that would have any input and would be informed about this new resin, right? We also the interviews averaged in 1 hour and were recorded, transcribed, and coded using computer textual analysis software. And this is a funny interesting because by coming from engineering, I did have to learn about how to collect qualitative data. What happens is there is a lot more work, I would say, than quantitative data, because the fact that it's subjective, there is a huge effort to provide clear information, solid information, more and more evidence that can support end conclusions in analysis. So it's actually very complex and takes a long time to collect qualitative information. But then yet, it's extremely interesting because we hear things that actually matter. So I remember presenting a summary of our research to the big meetings with the scientists, and much for my surprise and delight, the scientists were actually they told me that they always look forward to our presentations because it was very good to get to know what the stakeholders, what the potential adopters were thinking about the research that they were developing in the lab. So this would give them a context of the utility and the meaning and the potential benefits of what they're doing in the lab that they appreciated a lot. So it was very good to hear that from them. So as I mentioned before, we try to use information to help us identify relevant variables and define assumptions needed to develop the LCA. So basically, we're trying to give the LCA a little bit of more context-specific character as opposed to just using generic data or secondary information. And this is particularly useful when the quality of the data at this point is very low because the technology is being developed. So here I have an example of a quote from a representative of the wood composite industry. He said, "There is the California Air Resource Board, CARB, rules that come into effect a few years ago that limited the formaldehyde emissions and had really driven some adhesive development in the US and really elsewhere. Anyone that wants to sell them to the US because of CARB, so that's an important factor." So that drew our attention to the importance of formaldehyde emissions when we were conducting the LCA, because it's something that we could get back to them and give some useful information. Our quantitative data, so we used CIMA-Pro software to run our preliminary life cycle assessment, comparing the proposed new lignin phenol formaldehyde resin with the incumbent technology. So data on the new resin composition with different percentages, and then we used recipes, let's say, that of the new resin that had 10%, 20, 30, 40, and 50% replacement of phenol with lignin, but all based in laboratory results, right? There was no pilot plant at this point. So we compared the initial capital costs of the lignin phenol formaldehyde resin with the traditional resin due to transportation distances. And this was, again, an example of when the qualitative data interacts with quantitative, because it was based on our interviews that it was drawn to our attention of the importance of the transportation distances and costs to the final cost of the product. So we try to get it to a preliminary information in terms of cost as well, but it was also driven by what the stakeholders were pointing us as the key issues that we should look into. And this is one of the LCA graphs that we can get from the application of the CIMA-Pro software. This is particularly the recipe that uses 20% replacement of phenol with lignin. And we can see This represents basically a proportion of the presentation of the traditional resin, which is in red, with the proposed new resin. So you can see that overall, looking at this, the various impact categories in this X, that overall the new lignin-based resin presents or has the potential to present a much lower environmental impact. And I just have to say something interesting that happened during our research as well. The very first graphs of this research actually looked not so good, especially related to ozone layer depletion. And that was because in the new resin recipe, you have basically lignin, formaldehyde, and phenol. And the scientists were using too much formaldehyde in their starting recipes, let's say. And when we ran the very first LCAs, and the ozone depletion was very bad for the new resin, we went back to the scientists and told them that they should consider perhaps reduce the amount of formaldehyde in the composition of the new resin. And they actually did, and you can see here that it's getting better. And they told us that they can actually improve those results. But it was very fulfilling to see a feedback from our research to the scientists and the application of this feedback while they were at this early stage of the technology. So this is still has room for improvement, but you can still see that it was a nice useful information that we could provide to the scientists. And another interesting thing that we found now, starting to look into what were the results, further results of this research, is that there were many trade-offs and tensions between environmental, social, and economic aspects of this technology, right? We found that, for example, based on the current technology or the current stage of the development in the lab, the most favorable thermal property of the resin is achieved at 20% replacement of phenol. However, if we look at what composition is best in terms of providing lower environmental impact, then we can say that it's 50%. But there is this tension between getting a better environmental impact and reducing or compromising the technical characteristics of the new resin. So that was one of the tensions that we identified in our research. And not only that, but we could identify exactly what kind of proportions were looking better and were looking worse in terms of those two variables. The other thing is that although most impact categories for the new resin are lower than the traditional resin, but yeah, then significant improvements in environment performance is reached. So the message here would be that given that there is a significant difference between 20 and 50% of lignin replacement, the technology developers could focus their effort on solving the technical, more specifically thermal deficiencies when using higher percentages of lignin. So if they really want to pitch this technology as more environmentally friendly, so they could see that there was quite a room to grow between getting the technical performance in a stage that they were happy if they have to move from 20 to 50%. And also we looked at cost issues. One of the things that we identified during our interviews is that pennies matter in this research. So we estimated that the cost savings of producing the lignin resin compared to the traditional resin could be approximately 16 cents cheaper per kilo of resin at 20%. So since they said that the industry is so price sensitive, that would be helpful for them to know that. So while input materials cost of LPF resin look favorable, transportation costs vary substantially by distance, and the capital costs are also considerable. So we actually made calculations simulating actual distances from the pulp and paper, the pulp mill and resin manufacturers. So that actually happened to be in British Columbia, and we got those numbers. So, for example, the resin manufacturer increases from $625 per load when shipped 8 kilometers, which is a real distance from a real facility close by the pulp mill, to $2,600 for a resin manufacturer that is 480 kilometers away. And again, this helps them to look into what issues are going to influence the final price, and obviously are going to influence the commercial viability of this new technology. So we would like to propose also that using LCA to support an equal value proposition can help the technology. Our interview data indicated strong support from stakeholders to adopt renewable alternatives to petroleum. There is an agreement in the society that greener technologies are welcome. And also have low formaldehyde level, which is favorable to LEED for certification. LEED stands for Leadership in Energy and Environmental Design. So this is a common certification used in the US. However, we also found that stakeholders expect evidence of such benefits, especially industry, right? This is another quote from that came from our research. This one is from the forest industry representative. He said, what LCA can do is provide a perspective on what are the issues that the decision maker needs to take into account. But I don't think it's a substitute for an informed process, including stakeholders, to actually be able to frame how those tools will be used for supporting whatever decision is reached. So it's nice that there is this acknowledgement of the combination of several sources of information in order to make decisions, and which is quite expected from complex decision environments when it comes to sustainability, when it comes to developing and adopting sustainable technology, right? So for implications and conclusions, we combined new technology development, supply chain management, and LCA literature to propose an analytical framework for more sustainable technology. Actually, what we are doing here is we are going back to our context setting and providing a form of why. I like to emphasize this for students because it helps to put in context why do we look into literature, why do we look into theory and other studies. Part of our job as students and researchers is not looking only at what, but also looking into why. So this is all part of the process of processing all this information and what can we learn from it. And because once you understand the why, you can transform it, adapt, improve it, right? So we drew on supply chain management and LCA literature to develop a framework that utilizes LCA at early stages of product innovation, as retroactive studies is recognized as not sufficient to overcome sustainability challenges. And we also draw on new technology development literature to develop our framework that seeks to identify not only technological and commercial, but also the societal component of all the uncertainties related to developing a new product. And with that, provide guidance on how those new technologies or products can be more effectively developed and avoid costs of fixing problems at later stages of the technology and commercialization of those new ideas, right? And something interesting that we noticed also during this research is that if we only use the technological lens, so we found that the best composition of the new resin is 20% replacement of phenol with lignin, because it gives the best technical and product quality characteristics. If you look into commercial lens, then we found that the new resin is unlikely to generate sufficient industry interest, given the high capital cost in an industry that is very price sensitive. And then if we use the societal lens, we found that there is a potential market for more sustainable products. People are interested and they welcome green technologies, but also there is a need to prove that this new technology is price and performance availability is there, right? At least is similar to the current technology, but ideally it needs to be better. It needs to provide better prices, and it needs to provide better technical performance than the current technology used. But then if we combine those lenses as opposed to use them separately, then we have an integrated sustainability lens, which can allow us to identify opportunities that would be otherwise refuted. So a key challenge related to the new resin is to balance high technical performance with low costs while assuring positive environmental attributes. And then the environmental benefits of the new resin, when compared to the traditional resin identified through the LCA study, may be used to build an equal value proposition to this new technology while maintaining industry interests, while researchers continue improving the technological and economical commercial criteria and variables for that technology. So although stakeholders' perceptions of the resin based on renewable feedstock are very positive, LCA results can provide this supporting information for improved environmental performance of the new resin when compared to the other alternatives. And with that, I finish my presentation. Thank you very much.
Thank you so much, Dr. Matos, for your time. So if you have a few minutes, maybe we can open some questions and discussions.
Sure.
Okay, so does anyone have questions or thoughts? Okay, maybe I could start with a question. So one of the thoughts I had, and one of the things that you discussed in your presentation, was that it's harder to make changes for sustainability through the end of a life cycle rather than the beginning. And I was wondering if for large enterprises, it's actually harder to employ LCA and create sustainable development for their products rather than startups who, they're frequently changing and they're smaller companies, so it's easier for them to employ, new insights and I guess improve their products to be more sustainable. So would you say that that's true in light of the fact that it seems that it's easier to employ sustainable development in I guess with some insight into the environmental impact and so on in the beginning rather than towards the end.
You mean in the beginning of the establishment of a company?
Yes. So, for example, startups would be easier.
I would say so, that it could be easier. If we think about how hard it is sometimes to change the culture of a company, right? The older a company is, the more ingrained that particular culture it is in their decisions and the working environment. So unless, of course, it just happens that that company it really takes sustainability seriously, and it's willing to overcome those barriers of established behavior throughout the employees or the decisions that they make. So I would say yes, if a company it's being established, and if we have the chance to incorporate some sustainability principles in the beginning of that company, that should be much easier to start with that way of thinking, which is much more constructive. And I would say that a company that is being established, it must be very time consuming and expensive as well to change the whole culture if that company is not sustainable yet.
So in that case, showing them that there's a lot of benefit to becoming more sustainable in one aspect of their product or process is more important, I guess, to these companies, or not, I wouldn't say more important, but would help the process of them changing more than it would for companies that are just new and starting up and have newer ideas.
Yes, I think that established companies nowadays are under pressure, and if they think that they are not, it's a mistake. That they do think they're not under pressure to consider sustainability in their operations and in their decisions. And we have some cases of companies that went through really hard times because they thought that only by doing the technical stuff right, that would have been enough to not get in trouble. And society knows that it's not enough anymore just to be environmentally friendly.
Right.
More and more the society is requesting, what about your social responsibility? What about, how do you balance what you do with concerns over, important issues like slavery, modern slavery, which is a hot topic today, responsible resource consumption, and environmental issues as well. So I think it came to stay, and it's crazy to think that a company, no matter how benign their operations are, to think that they don't have to worry about any sustainability or social concerns, especially in this supply chain area. Because if one of your suppliers, you're doing everything right, but you are dealing with a supplier that is not doing right, the responsibility may come to you for some reason. So it's amazing how complicated things got, but it came to stay. It's here to stay, and everybody needs to consider it.
Thank you.
I want to ask a question about your case study. So, how did you evaluate the environmental impact of the PF and LPF?
Right. What we did, there was a life cycle assessment study conducted with the traditional resin, the phenol formaldehyde resin, And we were so lucky to have access to every single detail of this study, which also used the CIMAPRO software. So what we did, the difference is that the traditional doesn't have lignin, right? So what we did, we ran the CIMAPRO simulation with the composition of the new resin, which involved the lignin, formaldehyde, and the phenol. And by adding lignin, I'm sure you know that adding lignin, you add all the steps in the process, and by reducing the amount of formaldehyde, we change the environmental impact related to all the steps of the process related to the production of phenol, and all relative to 1 kilo of resin produced as our unit of analysis. So our starting point was this LCA study with everything in detail, which is very rare to obtain. So we were very lucky, because usually companies or consultancy firms keep this data hidden. But we had a solid source. It's a credible source of LCA study, and so we replicated, but we changed the composition of the resin in this study.
How the user react to these changes? The percentage of phenol.
The consumer or the resin manufacturer?
The consumer.
Oh, yeah. Oh, very positively, because formaldehyde was actually considered carcinogenic by the California Air Resources Board, right? And that's why it motivated the resin manufacturers to look for other ways, more environmental friendly ways of producing resins. And the consumers definitely take it very positively. I think it's the same phenomenon that happened with the painting of walls, right? You reduce the lead content, and that was taken very positively by consumers. So anything that reduces toxicity in their houses, it's welcome.
Thank you.
Well, and related to the previous question, I'd like to ask you that you told in your presentation that you had the support from stakeholders for your project. So there is a low cost of producing this, but higher transport costs. But if they didn't give enough support, would consumers do something to raise money or to do something in order to compensate the support that the stakeholders didn't give you? I mean, like environmentalist groups, would they stand up to do something and to support this project, even though the government wouldn't support it because of the higher cost?
I think actually in that particular case, the government wasn't involved with the overall cost of production. It was more a challenge for the industry to find more economically viable ways of producing without affecting the price of the end product. So in fact, one of the challenges is to come up with a more environmentally friendly product that it is produced in a very economically way, right? So that was useful because the developers could take that in. I'm sure that the cost is the first thing that everybody thinks about if you wanted to come up with a new product and put in the market. But then if the product, and this is what we were suggesting, but if the product has an equal value proposition, so that could perhaps justify the final product being a little bit more expensive compared to the traditional resin, but so keeping the industry interest while the scientists kept going in studying and improving the process to reduce costs and maintain the environmental benefits of that technology. So another issue that is involved in that is it's very controversial to know how much more the consumers are willing to pay for a more environmentally friendly product. There are many studies that try to address this issue. And I think there is a study that says that people are willing to spend up to 25% more of, let's say, an organic product or an organic or more environmentally friendly product. So perhaps this can give the new product a little bit of room to charge more, let's say, for the new resin. But everybody that is developing this new technology know that the ideal is to come up with a product that is at least the same cost of the traditional one, or even less is better. So that is the ideal point that everybody wants to reach. But again, it was more a developer challenge than a government challenge in this particular situation. I know that other technologies and other countries can involve the government as a subsidy to help, so population can have access to more friendly technologies as well.
Thank you.
Perhaps I could ask another question. Can you hear me clearly?
Yes.
So I read a bit of your paper on managing stakeholder relations when developing sustainable business models, the case of Brazilian energy sector. And
Yes.
we also talked a little bit in the presentation as well about sort of this theory, the theory on sustainability and sort of the studies that you do versus the practice and how to help scientists or business people or the industry make practical decisions and apply this theory. And what I'm interested in, and I know this is a bit unrelated to the topics that we've been discussing today, but I think you could still speak some wisdom into us, is that how can we as engineering students take this theory that we've learned on sustainability or the social impact or the ethical impact of, the things that we've been learning, the projects that we have or we may have in the future, how can we put those into practice? And how is it meaningful for us as students rather than people that are directly in the industry?
Right. I think you students have a wonderful opportunity to start things right. We've learned a lot from bad examples, but I think more and more the importance of sustainability is going everywhere. And as engineer students, I think it's important to realize that specificity and too much focus in one attribute of whatever you're developing may stop you from seeing important factors that can affect the utility and the potential benefit of whatever you're working on. So I think when I was an engineer student, there was no such call for this broader way of thinking. It was absolutely just numbers and quantitative that matter. But I think this is changing because there's no point in developing, in having a great idea if it has a limited adoption for some issue that if you have looked into some social component, you have detected that. And perhaps if it is early enough, you could have changed your idea or program or technology that you're developing. I do believe that the solutions for sustainability problems that we are facing now will come from the scientist lab, will come from the engineers lab. However, only looking to other issues that are related to this technology, it's when we have the chance to really benefit from its full potential. So it's time to open up our minds and incorporate and see further away of what kind of issues may be related to what we are developing, and then that will make a big difference in terms of effectiveness of getting this project or idea or new process adopted. And I think that the social sciences can help identifying these issues that, of course, it's a lot to take from engineers to expect to know everything, to be able to detect everything. So I think collaboration is key, and we can draw on different attributes and different sources of information to have a full, a comprehensive opportunity being put in practice, being, in the living room, being adopted, and you will see it in the living room of everybody else.
Mm-hmm. Thank you so much. Does anyone else have questions? Okay, I think we don't want to take too much of your time anymore, so thank you again so much for this wonderful conference, and thank you so much for your time.
Oh, it was a pleasure. Thank you so much.
We hope we can see you again sometime.
Thank you. Thank you very much. Me too.
Bye. Have a good day.
Bye-bye.